Let's look at linear approximation, also known as linearization. This is where we use the tangent line to a function at a point A to approximate, and that's a key word, approximate function values near point A. So for a function, we're approximating its values near where x is equal to A. L of x, or the linearization of x, is equal to f of a plus f prime of a times the quantity x minus a. This is the equation of the tangent line. And comes from that point-slope form of a line, which we've been using earlier in the semester. Except instead of writing y, we're writing L of x. Instead of writing x1, we write a. And instead of y1, we have f of a. And instead of m, we have f prime of a. So basically, it's just the same thing with function notation. If we look at a picture of a graph to try to help us with this, if we're looking at L of x at a is equal to 1, that would be the tangent line at a is equal to 1. And it's important to note the gap between L of 0.99 and f of 0.99. L of x is an approximation. It will not give us the exact value most of the time, but a large part of math is concerned with approximating things. A lot of calculators can't calculate something like the square root of 0.9854 exactly, but they can find an approximation using either linearization, or later in Math 152, we'll extend the concept of linearization to Taylor series and Taylor polynomials, which are also ways that we approximate functions. So this first bit of a Taylor series is linearization, or linear approximation. And we can extend this further by taking many derivatives to get a Taylor series or Taylor polynomial. But again, Calc 1, just this first bit. That's going to happen a lot because my laptop hates me. So apologies for the zooming. Okay, let's take a look at how to use linearization to make an approximation. So if we have a function f of x is equal to x to the 5th power plus 2x cubed minus 3x plus 5, and we're looking at a is equal to 1, in order to approximate f of 1.05. So in this case, the x that we will later substitute into our linearization is 1 5/10. Sorry, 5/100. So there's a couple steps. Our first step is to identify the function. Sometimes this function will be very easy to identify. Sometimes it will have to require a bit of thinking. In this case, they explicitly give us the function as f of x is equal to x to the 5th power plus 2x cubed minus 3x plus 5. Next, we want to either identify or choose our a value, which is that x1 from the point slope form. In this case, they give us that a is equal to 1. I'm going to circle this because it's one of the values that we'll be directly substituting into that L of x. Next, we want to find f of a, which is that y1 from our point-slope form. So we need to substitute a into our function. In this case, a is equal to 1, so we're finding f of 1 is equal to 1 to the 5th power, plus 2 times 1 cubed, minus 3 times 1, plus 5. So f of 1 is equal to 1 plus 2 minus 3 plus 5. So f of 1 is equal to 1 plus 2 is 3 minus 3 is 0 plus 5 is 5. So f of 1 is 5. We need to find f prime of a, but before we can find that, we have to find the derivative. So just find f prime of x. So we need to take the derivative of f of x. So f prime of x is equal to, using the power rule, 5x to the 4th power plus 6x minus 3. I don't know why it's happening quite this much. We can then substitute in order to find f prime of a, which is our slope. F prime of 1 is equal to 5 times 1 to the 4th power plus 6 times 1 minus 3. So f prime of 1 is equal to 5 plus 6 minus 3, which is equal to 8. Now we have all of the pieces that we need in order to find the linearization. So let's do it. We know that L of x is equal to f of a plus f prime of a times the quantity x minus a. So the linear approximation for our function at a is equal to 1 is f of a, which is 5, plus f prime of a, which is 8, times x minus a, where a is 1. And this is the linear approximation at a is equal to 1. The next part of our question asks us to use this to approximate. We're trying to approximate f of 1.05, so that means that x is equal to 1.05, or 1 in 500. So we need to find L of 1.05, which is equal to 5 plus 8 times 1.05 minus 1, which is equal to 5 plus 8 times 0.05, which is that 500, which is equal to 5 plus 8 times 500, which will be 4 tenths, because 8 times 5 is 40. So we have that L of 1.05 is equal to 5.4, which approximates f of 1.05. Let's try out a different function. So let's find the linear approximation of the function f of x is equal to the square root of x at a is equal to 1, and use it to approximate the number f of x is equal to the square root of 5/10. So this 5/10, just the 5/10, is x. First step is to identify the function. F of x is equal to the square root of x. Next, we need to identify or choose a. We are given that a is equal to 1. Now we need to find f of a. So we need to substitute 1 into our function. So f of 1 is equal to the square root of 1, which is equal to 1. Eventually we want to find f prime of a, so we'll start by finding the derivative of our function. So f prime of x is equal to the derivative of the square root of x, which is equal to 1 over 2 root x. Now we need to find f prime of a. F prime of 1 is equal to 1 over 2 times the square root of 1. So f prime of 1 is equal to 1/2. We have all the pieces that we need to write the equation for the tangent line, that linearization. So L of x is equal to f of a plus f prime of a times the quantity x minus a. So the linear approximation for the square root of x at a equals 1 will be equal to f of 1, which is 1, plus f prime of a, which is 1/2, times x minus a. Since a is 1, that is x minus 1. And this is the equation of the tangent line that we will use to approximate. This question asks us to approximate f of x is equal to the square root of 1, of just 5/10. So that means we're looking at x is equal to 0.5. So we need to find L of 0.5, which is equal to 1 plus 1/2 times 0.5 minus 1, substituting in that 5/10 for x, which is equal to 1 plus 1/2 times the quantity 0.5 minus 1, which gives us negative 0.5. So that's equal to 1 plus 1/2 times negative 1/2, which is equal to 1 minus 1/4, which is 3/4. So the square root of 5/10 is approximately 3/4. Let's take a look at some trig functions. We have some useful radians and degrees for these functions, where 1 degree is equal to pi over 180, 30 degrees is pi over 6, which is equivalent to 30 pi over 180, 45 degrees is pi over 4, which is equivalent to 45 pi over 180, and 60 degrees is equal to pi over 3, which is equivalent to 60 pi over 180. This will be pretty useful for sometimes finding an a value, and often evaluating the linear approximation in order to approximate something. So let's start here. We want to find the linear approximation of the function f of x is equal to sine of x at a is equal to pi over 4, and use it to approximate the number f of x is equal to the sine of 44 pi over 180. That 44 pi over 180 is the x we will eventually substitute in. Notice that it is very close to that 45 pi over 180, which is the pi over 4 that we're using for a. So let's start by identifying our function. And in this case, they give us that f of x is equal to the sine of x. And next we need to identify or choose our a value. In this case, they give us that a is equal to pi over 4. We will then use this to find f of a. F of a, so f of pi over 4, is equal to sine of pi over 4. So f of pi over 4 is equal to the square root of 2 over 2. Next, we'll find the derivative of our function. So f prime of x is equal to the derivative of sine of x, which is cosine of x, which we will then use to find f prime of x. So we need to find f prime of 1, which will be equal to, so many ones I forgot, f prime of pi over 4, which is equal to the cosine of pi over 4. So f prime of pi over 4 is equal to, also, root 2 over 2. We can then use this information to find our linearization. So L of x, the equation of our tangent line, and in this case, a is equal to 1, will be equal to f of 1, which is the square root of 2 over 2, plus f prime of 1, which is also the square root of 2 over 2, times the quantity of x minus a, which is the quantity of x minus 1. We then need to use this to find our linearization. To approximate our function. Reading the wrong thing. So we're trying to approximate the sine of 44 pi over 180. So we're looking at x is equal to 44 pi over 180. Don't want to zoom. I'm not trying to zoom. So we need to find L of 44 pi over 180, which will be equal to the square root of 2 over 2, plus the square root of 2 over 2, times 44 pi over 180 minus pi over 4. This is where one of our equivalent fractions will come in handy. So this is equal to the square root of 2 over 2 plus the square root of 2 over 2 times 44 pi over 180 minus pi over 4, which is equivalent to 45 pi over 180. You could have also found the common denominator of 180 the old-fashioned way, but it's a little bit easier to just know those equivalent fractions. So this is equal to the square root of 2 over 2 plus the square root of 2 over 2 times 44 pi over 180 minus 45 pi over 180, which gives us negative pi over 180. Which is actually simplified enough for our needs. So sine of 44 pi over 180 is approximately equal to the square root of 2 over 2 plus the square root of 2 over 2 times negative pi over 180. If you wanted to factor out that root 2 over 2, you could. So if you wanted to write that as the square root of 2 over 2 times 1 minus pi over 180, you could.